Hello, Chem 110. This video is an introduction to the concept of limiting reagent. Limiting reagent problems are just a specific kind of stoichiometry problem, and there's certainly no new math in these kinds of problems. There's not even really new chemistry in these kinds of problems, but they have their own particular set of things you need to do, so we'll go through that. So we're going to focus today just on this one reaction, hydrogen plus nitrogen going to make ammonia. This equation is already balanced for you. And I'll just start with this question, which if you have 2.5 mole of hydrogen, how much nitrogen do you need to react with it? And this is a stoichiometry problem that you've done something like this before. So you can go ahead if you want and stop the video and answer it, and then come back and see my answer. This is just sort of a stoichiometry review. All right, so our starting point here is 2.5 mole of H2. The mole ratio, we're trying to find out how much nitrogen we need. So we use the mole ratio of nitrogen to hydrogen, 1 to 3. My moles of hydrogen cancel out. And the answer I get with 2 sig figs is that I need 0.83 mole of N2. And I can even annotate this, needed to react all my H2. Okay, so that's a problem you've done before. So limiting reagent is a question like this. So a limiting reagent. So first of all, a reagent is, I don't know, I use it interchangeably with reactant. It's a limiting reactant problem as well. Limiting reagent problem would be something like this. If I have 2.5 mole of H2, so just like I said above, and I have 1.3 mole of N2, what happens? And I'm asking the question broadly, what happens? Normally the question that we would ask is how much product, in this case ammonia, can you make? So you just calculated above, hopefully, that for 2.5 moles hydrogen, you need 0.83 moles N2. So I would describe the problem this way. We need 0.83 mole N2. We have 1.3 mole N2. So we have more N2 than we need. And we have a term for that, which is excess. So we have excess N2. And if you have two reagents, one is the excess, and the other one is the opposite of that, which is it is the limiting reagent. Because we have more N2 than we need, H2 will run out before the N2 does. In this case. So H2 is the limiting reagent, and I like to just abbreviate that on my paper as LR. Okay. So what will happen is described here. The H2 will run out before the N2, and to get specific about how much product we make, well, this is sort of the key point. The limiting reagent determines how much product you can make. So as much, in this case, H2 as you have is as much product as you'll make. So to calculate, in this case, to calculate the amount of ammonia produced, the starting point is always the limiting reagent. And so in this case, the starting point is the H2. So we start with 2.5 mole H2. We see that we make 2 moles of ammonia for every 3 moles of H2. And if you multiply that out, you get with 2 sig figs that you will make 1.7 mole of ammonia. And that's what you get when you mix 2.5 moles H2 and 1.3 mole N2. It's also what you'd get if you mix 2.5 moles H2 and any excess of N2. Okay, so now I want you to think about this question. So same reaction, the one balanced up top. So now, question, how much ammonia is produced when you mix 6.24 mole of H2 and 1.98 mole of N2? And so I'm just going to outline. So step 1 is identify the limiting reagent. And you do this, there are a few ways to do this, but the way I like to do it is just to pick one reagent, and it doesn't matter which one. I'm going to go through both when I do the answer, but just pick one reagent. Using your stoichiometry skills, calculate how much of the other reagent you need to react with all of it. All right, that was the first thing we did, was figure out how much nitrogen we needed to react with the HT. So you pick H2, pick one reagent, calculate how much of the other reagent you need to react with all of it. If you have more than you need, that is the excess. If you have less than you need, that second reagent is the limiting reagent. And whichever one isn't the excess is the limiting reagent. So you'll identify one. And then once you've identified the limiting reagent, step 2 is use the limiting reagent as your starting point to calculate product. And you'll notice for today, I'm just working solely in moles to get at the heart of the limiting reagent. So you can answer this question in moles of NH3. You're welcome to stop the video now and then come back and see how I solve this. And as I said, I'm going to solve it a couple different ways. Okay, so step 1, which is the limiting reagent? So there are 2 ways to answer this. You only need one. Just pick one. You don't need to do this, but I'll do both just in case you did one or the other. 2 ways to answer this. Choose only one, and just doesn't matter which one you choose. Okay, so for instance, I can start with the hydrogen. So I was given 6.24 moles of H2. And so to calculate how much N2 I need, and I like to label this, by the way, I have 6.24 moles of H2. So if I want to calculate how much N2 I need, I use the mole ratio from the balanced equation, and I calculate 2.08 moles N2. And right away, I write under this need, because otherwise it's easy to get confused. So in this problem, you have up here 1.98 moles N2. That's what you're given. So I like to, when I calculate something, be very clear what I'm calculating. I have 6.24 moles of H2. I need 2.08 moles of N2. And I can then compare this to, I have, as I just said from upstairs, up in the thing, I have I don't know why I said upstairs, 1.98 moles of N2. So I have less than I need, or I need more than I have. So from these 2 points, I can say N2 is the limiting reagent. And I'm ready for step 2. I'm ready for step 2. I'm just going to show you that it doesn't matter which way you calculate it. I want to be very clear. You don't need to do this. If you did it the other way, this is what you would have gotten. You would have said, well, I have 1.98 mole H2. And again, I strongly encourage you to write down, I have that. And then if you're going to calculate how much H2 you need, here the conversion factor flips because you're trying to calculate H2. And you would calculate 5.94 moles of H2, and again, I write under it very quickly, that's what I need if I'm going to react all my H2. Okay, so what do I have? I have 6.24 moles H2. I have more than I need of H2. Like I said, 1 is the limiting reagent, 1 is the excess. So if you calculated this, because H2 is the excess, by definition, N2 is the limiting reagent. Okay, so you only need to do one of these ways of calculating. Either way, you are ready for step 2, which is use the limiting reagent to calculate product. And so we do that. So we don't start with what we need, we have to start with what we have. Our 1.98 moles of N2 is the limiting reagent. And we use the fact that from the balanced equation, we make 2 moles of ammonia for every 1 mole of N2. And that gives us 3.96 mole of NH3. And that's how you do a limiting reagent problem. I want to just show you there's an alternate way to calculate product in a limiting reagent situation. And by the way, how do you know you're in a limiting reagent situation? So that seems like a good thing to say right here. By the way, you know you might have a limiting reagent anytime that amounts of more than one reactant are specified. So in this question, for instance, I said I mix 6.24 moles of H2 and 1.98 mole N2. So I gave you specific amounts of both. It's possible that I gave you exactly the amount you need of both of them, but that's unusual. And this is different from previous non-limiting reagent ones. So non-limiting reagent problems or situations use things like react to completion or react with an excess of whatever the other reactant is. And a couple of you asked me about that on the last quiz because I was being careful to make sure you didn't have a limiting reagent. Okay, so anyway, back to this. An alternate way to calculate the product is calculate the maximum amount of product you could make if you were able to react all of each reactant. And then the smallest amount is the one you can make because that comes from the limiting reagent. So this is it can be a shortcut if all you're asked is how much product do you make. This sometimes can be a quicker way. I don't usually do it this way for reasons we'll go into next week, but all right. So for example, here we saw that if you start with N2, which we'd already identified as the limiting reagent, we got 3.96 mole of ammonia. If you could react all the hydrogen, well, we had 6.24 moles of hydrogen. If we could react all of that, if we had enough N2 to react all of it, we would get this much ammonia using the mole ratio between ammonia and hydrogen, and we would end up with 4.16 mole ammonia. So in this case, you compare the two, and the one that's smaller comes from the limiting reagent, so therefore is true. Comes from limiting reagent, so is correct. All right, and anyway, you can do this whatever way makes sense to you. They all give you the same answer.